Hey everyone, welcome back to Channel Name. Today we're diving into the fascinating world of LED lights. We use them every day in everything from our phones to home lighting. But have you ever wondered how these tiny, energy-efficient wonders are actually made? Well, let's break it down. Before we jump into how LEDs are made, let's quickly go over what an LED actually is. LED stands for Light Emitting Diode. It's a semiconductor device that emits light when an electric current passes through it. In simple terms, LEDs convert electrical energy directly into light, making them incredibly efficient. Unlike traditional light bulbs, which rely on heat to produce light, LEDs use a process called electroluminescence. That's why they're cooler, last longer, and use less energy compared to incandescent or fluorescent bulbs. Now let's talk about the raw materials. The core material in an LED is a semiconductor. The most commonly used material is gallium nitride, or GaN. This is what allows the LED to emit light when electricity flows through it. Gallium nitride is ideal because it can handle high voltages and produces light in the visible spectrum. Different elements are added to the semiconductor to produce different colors. For example, adding indium creates blue and green LEDs, while adding aluminum can result in ultraviolet or red light. So the color of an LED depends on the exact combination of materials used in its semiconductor. Part 3. Manufacturing process. Alright, now let's get into the real magic, the manufacturing process. This is where raw materials are transformed into the tiny LEDs we know and love. The process begins with creating a wafer. A wafer is a thin slice of semiconductor material, typically made of gallium nitride or similar compounds. This wafer is grown using a process called epitaxy, where layers of materials are deposited onto a substrate, forming a crystalline structure. Once the wafer is formed, the next step is to create individual LEDs on the wafer. This involves using a technique called photolithography to etch tiny patterns onto the surface. These patterns form the LED structure, including the PN junction, which is where the magic of light emission happens. After the patterns are etched, metal contacts are added so the LED can be electrically connected. This is followed by cutting the wafer into individual LED chips. Each chip is just a fraction of a millimeter in size, but they're packed with all the elements needed to create light when powered up. Part 4. Encapsulation and testing. Once the LED chips are made, they need to be protected and packaged for use. This is where encapsulation comes in. The LED chip is placed in a plastic or ceramic housing, which not only protects it but also helps focus the light. For most LEDs, the chip is covered with a layer of phosphor to convert some of the emitted light into a different color. This is how white LEDs are made. Blue light is converted into white using a phosphor coating. Next, each LED is tested for brightness, color accuracy, and efficiency. Only the LEDs that meet strict quality standards make it to the final stage of production. Part 5. Final assembly and applications. After passing all the tests, the LEDs are ready for final assembly, where they're integrated into everything from light bulbs to TV screens and smartphone displays. Because of their efficiency and versatility, LEDs have revolutionized how we use light in everyday life. And that's how LEDs are made. From tiny semiconductor chips to the lights in our homes, it's an incredible journey of science and engineering. I hope you enjoyed this deep dive into LED technology. If you learned something new today, be sure to give this video a thumbs up and subscribe for more tech breakdowns. Let me know in the comments if you have any other topics you'd like us to cover. Thanks for watching, and I'll see you in the next video.